Today we are solving exponential equations and inequalities. Exponential equations can be solved algebraically or by graphing a system of equations based on the equation. Equations of exponential functions can be used to calculate compound interest. Compound interest is paid on the principal of an investment and previously earned interest. So you're earning interest on your interest. That's why it's called compound interest. The compound interest formula is that the amount in the account equals your principal times the quantity 1 plus your rate of growth divided by number of times it's compounded. That quantity all to the number of times it's compounded times time. So n would be, if it's compounded quarterly, that's 4 times a year. If it's compounded monthly, that's 12 times a year. So to solve these exponential equations, we want to have both of them in the same base. So 64 equals 4 to the third power, so we're going to replace 64 with 4 cubed. When taking a power to a power, we keep the base and multiply the exponents. Now that we have the same base on both sides, then we can set the exponents equal to each other. Now to isolate x, we subtract 1 from both sides and then divide by 5. For part B, our bases are 1/2 and 16. Both of those bases can be written as a base 2 power, so 1/2 is 2 to the negative 1, 16 is 2 to the 4th power. So if we replace those with equivalent base 2 powers, this is our expression. When taking a power to a power, we multiply the exponents. We're going to be distributing the negative 1 and distributing the 4. Now that our bases are the same, our exponents can be set equal to each other, and then we can solve for x. We want to get the variable to one side, so we would add 4x to both sides. To isolate x, we would add 20 and then divide by 12. Example 2. Since it began in 1966, the extremely high viewership of the Super Bowl has led companies to pay millions of dollars to advertise for just 30 seconds. The average cost of a 30-second advertisement during the Super Bowl can be approximately modeled by an exponential function where the initial cost is $58,000 and the average cost increases by 9.9% each year. Write an exponential function to represent the situation. So we're going to let C be the average cost of a 30-second commercial. The initial cost is $58,000 or 0.058 million. Our rate of change being 9.9% as a decimal is 0.099. So following the formula, the cost equals initial amount times 1 plus rate of growth to the x power, we get this equation. So we're going to simplify what we had in parentheses here. So our growth factor is 1.099. To solve it, we're going to use a system of equations. So for y1, we put what we had on the left, which was 1. And then for y2, we're putting the exponential expression that 1 was equal to. Then when we press graph, first we're going to set up our window. X is representing the years since 1966, so the number of Super Bowls. So we're going to go from 0 to 40 with an x scale of 2. Y is representing the cost of a commercial in millions of dollars. So I'm going to make the Y window going from 0 to 8 with a scale of 1. When we press graph, we see this horizontal line here is 1 million, and then the red curve, exponential growth curve, is the cost of that of a 30-second commercial growing over time. So we're looking for where do they intersect. When does it meet that $1 million mark? And that intersection is, to get that, we press second trace 5, and then you press enter, enter, and it intersects at 30.161. X is years since 1966, and Y means $1 million. We can also look at the table of that function, so keep scrolling up on the X values until you're looking in Y2 reaching 1, and then that we can see that happening here between the 30th Super Bowl and the 31st Super Bowl. That's where it surpasses the 1 million mark. So we would say that the first Super Bowl where the ad cost surpassed $1 million was Super Bowl 31. Luciana deposits $1,700 into a savings account that pays 1.8% annual interest compounded monthly. What will the balance be after 5 years? We're going to start with our formula. Her principal is her initial investment of $1,700. Her interest rate is 1.8%. 8%, which in decimal form is 0.018. If it's compounded monthly, that's 12 times a year, so using 12 for n. Simplifying that expression, our growth factor becomes 1.0015. When we multiply 12 times 5, we get 60, and then we can type that part into our calculator, and we get $1,859.97. This is the amount she would have in her account after 5 years. And lastly, property of inequalities for exponential inequalities. This is very similar to how we did the equation. So if the bases are the same and you have a greater than sign, then the exponents on the left is greater than the exponent on the right. So first goal is to have them written with same base. So 27 and 81 are both powers of 3. 27 equals 3 cubed, 81 equals 3 to the 4th. So replacing 27 with 3 cubed and replacing 81 with 3 to the 4th gives us this expression. When you take a power to a power, you multiply the exponent. So I'm distributing the 3 on the left, distributing the 4 on the right. Now our bases are the same, so we can focus on the exponents. The exponent on the left must be greater than or equal to the exponent on the right. So first we want to get the variable to one side, subtract 4x from both sides, and then to isolate our variable, subtract 18 and divide by 2, so we get x is greater than or equal to -19. Thank you for watching.